Welcome to the MATLAB video tutorial of project assignment 2. We are going to move the end effector of robot using inverse kinematics. We create 6 DOF SOP using table. When we press positive delta X button, the end effector of robot is moved in positive X direction. When we press negative delta X button, end effector is moved in negative X direction. Same conditions for delta Y and delta Z buttons. We can see end effector movement of ASOP in MATLAB GUI. End effector is moving in X, Y, and Z direction. Next task is connecting hardware, that is Arduino board. When we push connect button in MATLAB GUI, Arduino gets connected. Next problem statement is scrolling through axial slices using potentiometer. When I enable scrolling, blue LED in front of first potentiometer is lit, which shows that I'm scrolling through the axial slices. While scrolling through axial slices, I can adjust the range using two potentiometers. Axial slice potentiometers are calibrated through 0 to 27. Range selection potentiometers are calibrated through 0 to 255, which is the pixel value of MRI image. Next task is creating sagittal view from MRI dataset and scrolling through sagittal view. When I push sagittal view button in MATLAB GUI, sagittal slices are created from raw MRI data. Now when I enable scrolling through the sagittal slices, red LED in front of second potentiometer is lit. Since we have 35 sagittal slices, potentiometer is calibrated through 0 to 35, which is number of sagittal slices. We can adjust pixel range of sagittal slices using two potentiometer provided, which are calibrated through 0 to 255. Next task is creating coronal view and scrolling through the coronal view. Using potentiometer, we can scroll through the 45 coronal slices. White LED is indicator of coronal view. Potentiometer is calibrated for viewing 0 to 45 coronal slices. We can adjust range between 0 to 255 for coronal slices using two potentiometers provided. Next task is brightness and contrast control for axial view. While scrolling through axial slices, user can adjust brightness and contrast using brightness control button provided. 5 dedicated potentiometers control brightness and contrast of images. User can invert pixels of images to get more details of a particular region. First two potentiometers control low in and high in values. Next two potentiometers control low out and high out parameters of image. Fifth potentiometer controls gamma parameter of image. Using 5 potentiometers, user can control brightness and contrast of slice. Next, brightness control for sagittal view. User can control brightness and contrast for sagittal slices using same 5 potentiometers provided on breadboard. Range for low in, low out, high out parameters are from 0 to 1. Potentiometer for these four parameters are calibrated through 0 to 1. If value of low out parameter is higher than high out parameter, then pixels of image are inverted. Next task is brightness control for coronal view. User can control range, brightness, and contrast for coronal slices using same set of potentiometers. Fifth parameter for brightness and contrast control is gamma of pixel. Default range of gamma is from 0 to 2. Hence, fifth potentiometer is calibrated from 0 to 2. With combination of range selection, brightness, and contrast control, user can get best details of images. Next task is selecting region of interest through 10 axial slices. While scrolling through any slice, user can select region of interest using imcrop command provided in MATLAB. Selected region of interest or portion will be resized to 48 by 48 uniform array. Next task is 3D view of selected region using plot3 command. Selected array is concatenated in a three-dimensional array, and user will be able to visualize a 3D plot of selected portion. User can even select surf option to make a 3D model of selected region of interest. While making a 3D model, user can enter pixel value. Pixels below user entered value are automatically omitted. Another choice is using delineate triangulation method or cubic interpolation for making a 3D model. In delineate triangulation, user can set the pixel value. User can create a complete 3D model of axial MRI slices. Delaunay triangulation method or cubic interpolation method is used to create a 3D model of complete axial MRI set. User can visualize a complete 3D view of head.